Welcome to the deep dive. Today we're digging into blockchain oracles. These are basically the crucial links connecting blockchains, which are usually pretty closed off to the real world. They're a massive reason why things like DeFi, on-chain finance have grown so much.
Absolutely. And for this deep dive, we've got some great sources lined up. There's a comparison piece looking at the big players, Chainlink, Pyth, RedStone. That should give us a good feel for the landscape.
Okay.
We've also got a Reddit discussion that dives into Chainlink specifically, plus info on their staking, their tokenomics, just general background on Chainlink, and a broader explanation of what oracles even are.
Right. So our mission here is to get a clear picture. What are these oracles? Why should you care? Why are they so vital? And what are the main options out there? We'll try to, cut through the jargon.
Sounds good.
Okay, so let's start right at the beginning. What is a blockchain oracle in simple terms?
Well, the fundamental issue, the reason we need them is that blockchains are designed to be isolated. They're secure, self-contained ledgers, but that means they can't just reach out and grab information from outside systems. They can't access off-chain data directly.
So they live in the secure bubble, but the bubble doesn't automatically have windows to see what's happening outside.
Exactly. That's a great way to put it. Blockchain oracles are the things that build those secure windows, or maybe bridges is a better term. They act as intermediaries. They let smart contracts, those automated agreements on the blockchain, actually use and react to real-world information.
I saw one source use a sports betting example that made it click for me. Can you walk through that?
Yeah, sure. So imagine you have a smart contract set up to handle bets on a football game. The game ends. The smart contract needs to know the final score to pay out the winnings, right? But it can't watch the game. It can't check a news site on its own. So an oracle comes in, it reliably finds out the official score from a trusted external source, and then feeds that specific piece of data to the smart contract.
And that's what triggers the smart contract to execute the payouts.
Exactly. The oracle provides that trigger based on the real-world event. It's the trusted reporter.
Okay. I also kept seeing this term, blockchain oracle problem. What's the actual problem they're talking about?
Yeah. The blockchain oracle problem, our sources from Investopedia and Chainlink talk about this. It really boils down to a core tension. How can these smart contracts get the off-chain data they need without compromising the security and trustlessness that make blockchains valuable in the first place?
Because if it just pulled data from anywhere, that data could be wrong or manipulated.
Precisely. You'd be undermining the whole point of the secure blockchain. So the problem is finding ways to bridge that data gap securely and reliably.
Okay, so oracles are the bridge. But let's talk about why they're so fundamentally important. It seems like they unlock a lot.
Oh, they're absolutely foundational. Chainlink talks about them enabling the verifiable web. Think about it. Without oracles, smart contracts are mostly limited to things that happen purely on the blockchain.
Like transferring tokens.
Exactly. Oracles are what let them react to and interact with the real world. They turn blockchains from just ledgers into dynamic platforms. They unlock pretty much most of the interesting use cases.
And the range of uses seems huge based on our sources.
It really is. DeFi is the obvious one. Price feeds are essential for lending, borrowing, trading platforms. But think about insurance. An oracle could feed weather data to automatically pay out a crop insurance claim after a hailstorm.
Okay, yeah.
Or gaming. Providing verifiable randomness, so the in-game lottery or the NFT drop was actually fair. Supply chains use them with IoT sensors to track goods, even identity verification in some cases.
So it's way beyond just crypto prices.
Much broader. While price feeds are, a dominant use case today, especially in DeFi, the reality is that most potential smart contract applications rely on some kind of real-world data. Oracles dramatically expand what kinds of agreements blockchains can actually handle.
On essential tech, wide applications. But there's this distinction. Centralized versus decentralized oracles. Why does that matter?
This is a really critical point. A centralized oracle means you're relying on a single entity to provide that data, and that brings back the exact problem blockchains try to solve, a single point of failure.
If that one oracle goes down, or gets hacked, or just feeds bad data,
then the smart contract relying on it executes incorrectly. People could lose money. It totally undermines the trustless nature of the system. It's a major weak link.
Doesn't sound very decentralized.
It isn't. And that's why decentralized oracle networks, or DAWNs, were developed. As the Chainlink source explains, DAWNs use multiple independent oracle nodes. And they usually pull data from multiple independent sources too. So you have decentralization at the node level and often at the data source level. This makes the whole system much more resilient and trustworthy. It's way harder for any single actor to corrupt the data.
Like having several reporters confirm a story before it goes to print.
Exactly like that. Chainlink price feeds are probably the best known example of a dawn. They have layers of decentralization, different data sources, different companies running the nodes, the network structure itself. That's how they secure, billions and billions of dollars in DeFi.
Okay, the case for decentralization seems pretty strong there. So let's get into the main players we looked at. Chainlink, Pyth, and RedStone.
Right. According to that Wolf article comparison, these are 3 heavyweights in the Oracle space right now.
Yeah.
And fundamentally, they're all trying to do the same thing, securely connect blockchains to real-world data.
And for standard stuff like common price feeds on major chains, they're probably pretty similar in quality.
The article suggests that, for basic market data on established networks, the quality and accuracy are often comparable. But how they do it, their underlying tech and their strategic focus, that's where they really differ. And they've all been growing lately.
Let's start with Chainlink. They seem to be the veteran here.
Definitely. They have the longest track record. The Wolf article points out they pioneered the push model. Think of it like a broadcast. The Oracle network actively pushes data updates onto the blockchain maybe every hour or whenever a price changes by a certain percent.
So the data is just there, waiting.
Pretty much, yeah. Chainlink historically focused on EVM-compatible chains, the ones that work like Ethereum, and now they're building out cross-chain stuff with their CCIP protocol. They also use these things called aggregators.
Aggregators?
Yeah. Think of them as systems that collect answers from many different Oracle nodes and data sources, check for outliers, and then combine them into a single, highly reliable data point before it's put on-chain.
I also saw that Reddit discussion dive into Chainlink. It described it pretty simply as a bridge.
Yeah, that thread, particularly one user, Onaeronaut73, explained it well. They basically said Chainlink is how stuff like asset prices or maybe election results or weather data, how that information gets onto the blockchain so smart contracts can use it.
And they mentioned the decentralized network aspect too.
Right. They highlighted the network of independent validators or node operators running the Chainlink software. And the crucial part is that these operators have to stake LNA tokens, Chainlink's own crypto, as collateral.
Skin in the game.
Exactly. If they provide bad data or go offline, they can get their staked LNG slashed, meaning they lose some of it. It's a strong economic incentive to be reliable and honest. The network then aggregates all the valid responses to get a consensus price.
So the staking isn't just for earning rewards, it's fundamental security.
Yeah.
That Redditor also called Chainlink the Windows of Oracles. I thought that was interesting.
Yeah, that captures it well. Being the first major player to really solve this Oracle problem at scale and building such a widely adopted network gives them a huge network effect. Like Windows in the early PC days, the more people used it, the more developers built for it, which attracted more users, and so on.
Makes sense. And the Link token itself, we mentioned staking, but what are its main uses?
So yeah, the Shrimpy Academy and Investopedia sources lay it out. A Link is primarily used for 2 things. Paying the node operators for their service, fetching and delivering data, and, as we just discussed, for staking by those operators as that security deposit, that collateral.
Right.
And beyond the operators, other Link holders can also stake their tokens, contributing to the overall security of specific Oracle services and earning rewards for doing so.
And there was that V.2 staking upgrade. What changed there?
Yeah, the V0.2 upgrade launched late 2023, built on the first version. The main things, according to the staking page, were adding more flexibility, like an unbonding mechanism to withdraw staked Link. Crucially, it properly implemented slashing penalties for misbehavior. It also made the system more modular for future upgrades and introduced dynamic rewards, so rewards can come from more sources over time. The launch was phased, priority for existing stakers, then early access, then general access, with caps on how much could be staked initially.
Okay, so Chainlink, long history, push model, aggregators, big network effect, LENK token for payments and security via staking, which keeps getting refined. What about Pyth? How do they fit in?
Pyth took a different approach, really spearheading the pull model, according to the Wolf article.
The model.
Yeah, so instead of the Oracle pushing data constantly with the pull model, the application on the blockchain has to actively request or pull the data from the Oracle network precisely when it needs it.
Ah, so it's on demand.
Exactly. Pyth is designed for high-performance think, really fast updates, and supporting a very large number of data publishers, often first-party sources like exchanges themselves. Wormhole is also key for them. It's a cross-chain messaging protocol that helps Pyth get its data onto many different blockchains quickly.
So focus on speed, lots of publishers, and cross-chain via wormhole.
Right. The article highlights their optimization around publisher quantity, supporting perpetual futures markets, distributing randomness, VRF, and their own native staking design.
And then the third one, RedStone. The article said they were the fastest growing in 2024. What's their angle?
RedStone's approach is built around a modular architecture. The goal is maximum flexibility. They want to be able to support basically any kind of data, any asset on any blockchain, EVM or non-EVM.
Modular, so adaptable.
Yeah, think building blocks. Interestingly, they offer both push and pull models, and they do it cross-chain. So they're not tied to one delivery method like Chainlink, mostly push, or Pyth, mostly pull.
Best of both worlds, maybe?
That seems to be the aim. The Wolf article emphasizes their focus on broad ecosystem support, security, gas optimization, making transactions cheaper, scalability, and importantly, creating bespoke custom Oracle solutions for specific protocols.
Custom solution.
Yeah, like tailored data feeds. A key difference mentioned is their data sourcing. They often collect price data directly from on-chain sources, like liquidity pools on DXs. The article gave examples like a specific feed for a liquid-staked Bitcoin pair, a proof of reserves oracle for a specific lending platform using Bitcoin, and even things like validator data for liquid staking protocols like Puffer.
Okay, that's quite different direct on-chain sourcing in these tailored products. So summarizing the differences, Chainlink is the established leader, mostly push, uses aggregators. Pyth is focused on pull, speed, many publishers, uses wormhole. RedStone is newer, fast-growing, modular, offers push and pull cross-chain sources on-chain, and does custom builds.
That's a good overview of the key distinctions highlighted in the Wolf article. And it's worth noting, as the article points out, while pull models are innovative, the push model is still what most of the really big DeFi protocols tend to use right now.
Interesting. Okay, we also had a bit more detail on Chainlink's inner workings, the under-the-hoods stuff from that Kaleido article. Worth touching on the components.
We can briefly. The Kaleido piece breaks it down. There's an Oracle smart contract on the blockchain that kind of manages the whole process, handles requests, talks to the nodes, relays results, holds the LANK deposits. Then there's the client smart contract, that's the application needing the data. It uses a standard Chainlink interface to make requests easily.
Huh?
Then you have the Chainlink nodes themselves. These are the off-chain computers run by independent operators, listening for requests and doing the actual work of fetching data. There's the link token contract for payments and staking. And finally, jobs, which are like specific instructions telling a node exactly what data to get and how to format it.
And how do they interact? There was a request event response flow.
Yeah, basically.
Yeah.
The client contract makes a request. The Oracle contract logs this request, creating an event on the blockchain that the nodes are listening for. A node picks up the job, gets the data, and submits it back to the Oracle contract response. The Oracle contract then takes that data and calls back to the original client contract, delivering the information.
Request, event notification, node does the work, delivers the response back through the Oracle contract.
Got it. And just to quickly circle back on tokenomics Link's role.
Sure. As the Shrimpy and Investopedia sources confirmed, it's an ERC20 utility token. Launched via ICO in 2017, total supply capped at 1 billion LNK. Main uses: paying node operators staking it as collateral, which can be slashed, and also investors staking it to boost network security and earn rewards. It really fuels the whole incentive system.
Right. Now, beyond those core price feeds, Chainlink seems to do a lot more. The use cases page listed quite a few things.
Absolutely. Price feeds are foundational, but they've built out a whole suite of services. There's the verifiable randomness function, VRF. This provides provably fair random numbers, which is huge for gaming, NFTs, anything needing unpredictable but verifiable outcomes. Aavegotchi's dynamic NFTs were mentioned as an example.
Fair lottery draws on chain, things like that.
Exactly. Then there's automation, sometimes called keepers. This lets smart contracts trigger functions automatically based on time or other conditions without needing an external entity to poke them, like COTI's volatility index, using it to rebase automatically.
Okay.
There's CCIP, the cross-chain interoperability protocol, which is designed to let data and value move between different blockchains securely. Think about Swift using it for experiments with tokenized asset transfers across networks.
Moving assets between chains is a big challenge.
Huge. And then there's proof of reserve. This lets projects prove that the off-chain assets backing their tokens, like stablecoins backed by dollars or gold-backed tokens, actually exist. Cash Gold, using it to verify their physical gold reserves, is a good case study. Other examples mentioned included fair NFT minting, gamified savings, crypto supply adjustments, lots of applications.
It really shows how these Oracle networks are becoming broader platforms for decentralized services.
Yeah.
What about competitors beyond Pyth and RedStone? The PrimeXBT article mentioned others.
Yeah, it's definitely not just a three-horse race, though they are major players. The article briefly mentioned Band Protocol, which focuses on cross-chain compatibility and community governance. There's DIA, which emphasizes transparency and crowdsourced data validation. API 3 is interesting. They promote first-party oracles, trying to get data directly from the API providers themselves, and Teller uses a proof-of-work mining approach to secure data submissions.
So different approaches, different focuses.
Exactly. It's a dynamic space, lots of innovation happening.
And looking forward, that article also touched on Chainlink's 2.0 roadmap. What is the vision there?
The Chainlink 2.0 white paper outlines a pretty ambitious vision across 7 key areas. They talk about enabling more complex, hybrid smart contracts that blend on-chain and off-chain computation. Big focus on scaling, making everything faster and cheaper across many chains.
Makes sense.
They want to abstract away complexity, basically make it easier for developers to use oracles without needing to know all the deep tech. Confidentiality is another one, working on ways to handle private data with smart contracts.
Privacy is always a big topic.
For sure. Then there's order fairness, trying to prevent things like minor extractable value or front-running in DeFi. Trust minimization continues the push for ever stronger security and decentralization. And finally, crypto-economic security, which is about constantly refining the staking and incentive models to keep the network secure.
So really doubling down on making oracles more powerful, scalable, secure, private, and easier to use. It sounds like the evolution is far from over.
Absolutely. It's a space that's constantly pushing boundaries.
Well, wrapping this up, it's incredibly clear that blockchain oracles are just fundamental infrastructure. They're the essential connectors making blockchains useful for real-world applications, especially in DeFi. Chainlink is obviously the established giant with a wide reach, but competitors like Pyth and RedStone are bringing really interesting innovations and different models to the table.
Exactly. And understanding those differences, push versus pull, how they handle decentralization, the role of their tokens is pretty key to figuring out how this space works and where it might be going. The competition seems to be driving a lot of progress.
And you have to think, as blockchain keeps integrating into more areas, the need for reliable, secure, real-world data fed onto these chains is only going to grow. It really makes you wonder, doesn't it? What completely new things become possible as these Oracle bridges get stronger, faster, and more sophisticated? What haven't we even thought of yet that this technology will enable? Definitely something to ponder. Thanks for joining us for this deep dive.